Hey guys, we need to take a moment and talk about the biggest problem in all of physics, and it's an age-old problem. It's a problem of measurement. We're always trying to get better measurements of different things, but here's the thing. You can get into just as much problem with your interpretations of the measurements as with just having faulty or low resolution measurements. And that's what's happening to us today. It's not a problem with the resolution of the measurements. It's a problem with the interpretation. We've got this problem in quantum mechanics, but we also have this problem in relativity as well. And so what I want to talk about is relativity. And so to understand this, you need to know about something called gravitational redshift. So if you take a laser beam on the surface of the Earth and you point it up into the night sky, you shine it up at the International Space Station, then the wavelengths of that light, they started out as one wavelength, but they will appear to have stretched by the time they get up to the International Space Station. And this is called redshifting, gravitational redshifting of light. And so general relativity interprets this as the light actually changing wavelengths. But there's another way to look at this whole thing, and it is very interesting. So you can assume that the light hasn't actually redshifted at all. Well, it's redshifted, but you can assume that the wavelengths of light haven't changed. If the wavelengths appear to be longer once they get to the International Space Station, well, maybe they've always been that length, but they just didn't look longer when they were on the Earth. And what I mean by that is, I suspect, and I'm pretty sure, that gravity actually makes things bigger. So if your laser, it's inside of a gravity well, the laser is physically bigger. Each individual particle inside of that laser is bigger than if the same laser was outside of the Earth's gravitational field. And so for that reason, the laser is going to emit photons which are slightly larger. And so when those photons are received at the International Space Station, where things are slightly smaller, then the light is going to appear as if it shifted, as if it changed. But really, it didn't shift, it didn't change. What happened is that, it was just emitted differently. So this is what I'm talking about here with, with our interpretation of measurement. You can assume that the light is changing its wavelength, or you can assume that the light didn't change, but that something else has changed. So there are always problems with interpreting measurements. And if we ever want to move past the theory of general relativity, which is an amazing theory, but really it's wrong. And that's because space doesn't transform, space-time doesn't transform the way we think it does. Really, it's matter that's going through the transformations. And this is just an issue of measurement. How have we measured things? And how are we interpreting those measurements? Anyways, I hope this is interesting for you guys. Thanks for listening. I hope you leave a like. Hope you support me. I am gonna make a lot more of these videos in the future.